Hello everybody. Once more some short video about this how it's called now, Dr. Stephen E. Jones circuit, the old SJ1 as it was called. Someone on overunity.com made a nice new schematic. I printed it out. This did not have all the values in it, and the values that are in are not the ones I am using. The toroid windings turned out to be somewhat lower. I have to use 5 turns to get to this 90 microhenry, so 5 turns each. But then it was 82 microhenry, and if I took another winding, another turn, it was 118 micro. So I get stuck at 5 windings, 5 turns each, and then I get my 82 microhenries. The RB is a 100k potmeter I've installed. I have only 1.3 volts. The RR is 3.3 ohms in my schematic. I have a red LED, so also in line with what Physics Prof is using. And RO is 2 times 5k potmeters, totally 10k. And errors out is also 1 ohm. So I've redrawn this circuit and put in the values. The 1 ohm, 100k ohm there. I have 140 picofarad as capacitor. And the 2 times 82 microhenry, the 5 turns. I have a red LED, 1 ohm output, and I have the 10k ohm output resistor. My circuit is not grounded, and I'm using this input low pass filter to measure across the 1 ohm resistor, heavily filtered, to get some accurate reading, I hope. So this is my schematic. What I found out that if I put this RB at 50k, that's the value that Physics Prof is using, the input is about 2 microamps, the current, and that's measured across this 1 ohm resistor with this schematic. When I put it at the max at 1k, it's lower to 1 milliamps. But then I have to put this output resistor almost at very low, 1k or something, I guess. Otherwise this LED will not visibly lit. So I'm very close now, I guess, I think, to the circuit that Physics Prof is using. And in real life it looks like this. The 2 and 2 have the red LED. It's a little bit lit at the moment. I have the, what is it, the 100k potmeter on the yellow leads, and I have the 2 times 5k is totally 10k potmeters at the output. I'm measuring the input current across this input capacitor, and the value is, like I said, 1 milliamps, and the battery voltage is 1.309 at the moment. Oops, let me just go out. So when I calculate this wattage, it's about what is it, 1.25 or something milliwatts. Can do the calculations later on. But when I use the 50k on this potmeter like Physics Prof use, I still have this at 2 milliamps, and then the input, the wattage, will be something like 2.52. So there's a big difference. I think Physics Prof says he has only 230 microwatts then, so I'm not sure why that's such a difference. I again try to use my 4 capacitors as a battery, and did the 30-second calculations. And when I do this, even in this low value with 1 microamps being drawn, if I do the calculations correctly, after 30 seconds it calculates that the input wattage would be about 0.66 milliwatts. So that's very low. But if I take the value after 20 seconds, it shows 0.80 milliwatts, and I guess this is supposed to be the same. I mean, the input will be the same, I guess. So I'm not sure about this capacity measurements method. I think it does not work out. I still trust this this heavily filtered input circuit better. It gives steady outputs, and the calculations are wrong. I think they should be 1 after 20 seconds or 30 seconds. The same value should come out at milliwatts, and it doesn't. It's the same at my last video. I made the calculations for 5 seconds, what was it, 15 seconds and 30 seconds, and they all add up differently, but they should be the same as I understand it, because your calculation, the draw on the capacity. Okay, so I don't think I will continue any further about this input measurements with the capacitor or something. It will bleed dead in about 40 seconds or 1 minute with my 40 microfarad capacitors. So I think it's still drawing a lot of input. I will try now to get some measurements on the output, to see if I can find something there. I did find out that there's a big difference in either what you use, a LED, a small signal diode like the 1N4148, or a 1N4007 or 4001. They all give out different outputs when you put it into a capacitor. And the best results I get with a ultra fast diode I put in. Where is it? Here is it. I'm not sure what it is. It's a U860. It's an ultra fast, and then the value is the highest. The peak value measured on the scope is the highest. And now something like 6 volts output measuring across the resistor, but I think I will concentrate on getting the output up and put it into a cap to see what's much stable, and see if I can have some feedback. The problem is that the output is negative, so I cannot directly put it back to the input because I have a mismatch there. So I have to invert the output first from minus to plus. Perhaps I build a second circuit identical to this one and feed it with the negative, and then that output will be positive, and then I can feed it back, something like that. Okay, thank you for watching.